This is a whole worksheet in geometry, I was about to say geography, for finding sides and angles using trigonometry. Now, if I'm going to look for angles, I'm going to have to use the inverse functions, the arc sine, arc cosine, arc tangent. If I'm going to find sides, I'm going to use sine, cosine, tangent. So I'm going to do the last two first. If you can do the last one, you can do all of them. My high school algebra, and algebra 2 teacher used to say. So I'm going to do that first, then I'll do a few extra ones. I guess those are both finding angles, so I'll do these two finding angles, and then I'll do 2 finding a side. So let me do 11 first. I have the adjacent, and I have the hypotenuse. So I'm going to use cosine. Cosine x, now this is in degree mode, equals adjacent, 25, divided by hypotenuse. 5 goes into 25 5 times, 5 goes into 35 7 times. Now, when I'm looking for an angle and I have the trig ratio, I use the arc function. On your TI-84, it's going to be second. Cosine will be cosine minus 1. That's arc cosine. On Desmos, I'm going to use arc cosine. So x degrees equals arc cosine of 5/7. And I'm trying to see nearest degree. I'm gonna round the angle to nearest degree, and the lengths I round to the nearest tenth. Okay, very good. Arc cosine 5/7. Let me somehow find it here. Arc cosine, I'll make sure I'm in degree mode. Arc cosine 5/7. Whoops, I did 7. 5/7. Do what I'm telling you. And then I'm in degrees. So it's 44 degrees, approximately 44 degrees. It says round to nearest degree. Okay, this one, what do I have for this one? I have opposite and hypotenuse. So I'm going to do sine of x degrees equals opposite over hypotenuse. And that's going to be 14, I think it's 3. Yeah, 3. So 14 goes into 14 once, into 42 3 times. So sine of x equals 1/3. X degrees equals arc sine 1/3. And if I do that on my calculator, arc sine 1/3, I'm paranoid about always checking if I'm in degree mode. It's 71 degrees, approximately 71 degrees. Now if I do this, if I do sine 71 degrees, something is off. Oh, I did arc cosine. Whoops. Why didn't you tell me? See, I knew I did something wrong. It's arc sine 1/3. And so it's sine 19 degrees. So sine of 19 degrees. I had cosine up there. And it's about, you notice, it's 0.3255, which is about 0.33, which is 1/3. I'm rounding. So it's 19 degrees, not 71 degrees. I did arc cosine by mistake. And you didn't correct me while you were watching the video. You have to do some work. So this is 19 degrees. I need arc sine of 1/3. Approximately 19 degrees. All right, I did 2 where I found the angle. Let me find a side. How about this one, if I can see the angle? 38 degrees. So I have opposite and I have adjacent. So tangent, 38 degrees. It's a little bit blurry, so I'm pretty sure it's 38. If it's not, well, then I'm doing 38 anyway. I think it's 38. Tangent 38 equals W divided by 17. Opposite over adjacent. I multiply both sides by 17, and W equals 17 times tangent 38 degrees. I think you have to round this to 4 decimal places. 17 tangent 38 degrees. Make sure I am in degree mode. I already forgot. Round length to nearest tenth. Oh, not 4 decimals, nearest tenth. Okay, so this is 13.3, approximately 13.3. Okay, and now I'll do one more where I'm looking for length, number 2. Well, I don't know if I can do number 2. What is that angle? I cannot, you can see that angle is very blurry. I can't see that angle. So I guess I will do, can I see this angle? I think that's 50 degrees. I'll do it as if it is 50. If you happen to have this, well, let me do one where it's very clear. Boy, none of these are very clear. Here's one that's very clear. That's 25 degrees. I have opposite and I have adjacent. Well, I want to do one when I have something different here. Is it always going to be opposite over adjacent when I'm looking for the side length? Well, is that, oh boy. I can't, some of these I cannot read on this worksheet I got. I cannot read the angles. All right, I'm just going to say that's 50 degrees. If it's not 50 degrees and you have this worksheet, well, work it with your angle, but I'm just doing an example. So I have adjacent and hypotenuse. So I'm going to do cosine 50 degrees equals adjacent over hypotenuse. I want to do one where it's a little bit harder, so I'll try to find one more. So z equals 35 cosine 50 degrees. I'm imagining that that's 50 degrees. If it's not, then do it with whatever it is, if you know what it's supposed to be. Cosine 50 degrees. On test day, you should be able to read your paper. You didn't receive an email from a scan. So that's 22, approximately 22.5. Okay, not 22.5 degrees, 22.5. I'm not looking for an angle there. Let me find one where I'm going to have to, yeah, this one. I really can't see what the angle is there. Boy. I'm going to go with 30. It looks like 32 degrees to me. If it's not and you have the worksheet, do it with whatever angle is actually there. But I'm going to do it with 32 degrees. All right, so I have adjacent and hypotenuse. So that's cosine. Cosine, 32 degrees. It looked like 32 on, that's what I'm going to pretend it is, equals adjacent, 6 divided by hypotenuse, z. Now I'm going to find that side z, so I'm going to multiply both sides by z, so it goes away. And then I'm going to divide both sides by cosine 32. 6 divided by cosine 32 degrees. And 6 divided by cosine 32. 6 divided by cosine 32. And I have to be in degrees mode. I am. 7. Oh, man, I keep forgetting what I have to round to. Round lengths to nearest tenth. So that's going to be 7.1. This is approximately, this is the exact answer, which is approximately 7.1. And that's it. How to use these trigonometric ratios. If you're looking for the angle, you're going to have to use the arc sine, arc cosine, arc tangent. If you're looking for the sine, you just use sine, cosine, or tangent. The side. I think I said if you're looking for the sine. If you're looking for the side, you're going to use sine, cosine, tangent. If you're looking for the angle, you're going to use arc cosine, arc sine, arc tangent.